Hello everyone and welcome to Lesson 8 of the Algebra 1 summer course. This is going to be the last lesson of the summer and we're going to end on a good one. It's systems of equations. This is typically something you're going to learn towards the end of the school year. It is one of the hardest things in Algebra 1, in my opinion. And with that, let's look into it with a problem or at least an introduction. So basically, a system of equations is simply two lines that intersect at some point. So in other words, even though, like last week, for instance, we talked about, well, not just last week, but this entire summer, we've been talking about y equals mx plus b. We've been talking about graphing linear lines. Well, basically, a system of equations is just two lines, like this. And obviously, you can see where these points intersect if I give you a graph. Like, for instance, this point right here, that point is 3, 1, because it's 3 in the x and 1 up. So the intersection point is 3, 1. In other words, the solution is x equals 3 and y equals 1. And if I give you a graph, it's that easy. You just look at where the lines intersect. But what if I didn't give you a graph? Well, if that was the case, let's talk about how we solve the equations using system of equations. So for instance, the blue line here, which is actually easier to solve than the red line, the blue line to me looks like it has a slope of 1/2. And I say that because if you look from this point right here to that point right there, it looks like it's going up 1 and to the right 2. So the slope is 1/2. So therefore it's 1/2 x, y equals 1/2 x. And then the y-intercept, we're starting at negative 1/2 it looks like. So minus 1/2. And so there's our equation. Whoops, I have it for the wrong line. That's supposed to be the blue line. Sorry. There we go. So yeah, the blue line is 1/2 x minus 1/2. And then the red line, I can figure out the slope. The slope looks like, to me, it's negative 3, because each point it's going down 3 and to the right 1. So I know the slope is negative 3x. But now if I want to find the y-intercept, well, this is harder. Well, if I want to find the intercept, here's what I would do. I would say y equals negative 3x plus b. And then I would say I have this coordinate point here, 3, 1, that falls in the red line. So in other words, y is 1 and x is 3. And now I can just solve for b this way. So 1 equals negative 9 plus b. Add 9 to both sides. Looks like b equals 10. And so that's what I'm going to write. Y equals negative 3x plus 10. So right now, yes, go ahead.
Could you also do point slope form?
Yes, you can also do point slope form. I'm just going to do slope intercept form for right now because you're going to see it's helpful for system of equations.
Okay.
And basically, this is all stuff we've done in weeks past. So hopefully that was a quick review. But now, how would I solve this function? Well, it's pretty easy. Because the two y functions are equal to each other, I can just set the functions equal to each other. In other words, I can say negative 3x plus 10 equals 1/2 x minus 1/2. Now, I'll admit, this is kind of annoying with the fractions. So the first thing I'm going to do, and this is kind of an advanced technique, but you can do it. The first thing I'm going to do is multiply both sides by 2, and that's going to eliminate the fraction. So on the left, I get, distributing the 2, I get negative 6x plus 20. And on the right, the 1/2 and the 2 cancels out for both of them. So it's going to be x minus 1. And if you don't understand, let me know. But the 2 and the 1/2 cancel for both of those. And now from here, this is pretty easy. Because you would just add 6x to both sides. So now you've got 20 equals 7x minus 1. And then we would just add 1 to both sides. And it looks like 20 equals 7x. I'm sorry, 21 equals 7x. Which then means when you divide by 7, you're going to get a final answer of x equals 3. And isn't that what we said earlier? And then if you want to find the y value, well, that's easy as well. Because all you got to do is plug in 3 into this function right there. And if I do that, y equals negative 3 times 3 plus 10. I'm going to get y equals negative 9 plus 10. Looks like I get y equals 1, which is exactly what I said up here when I was looking at the graphs themselves. So that's one method of solving system of equations. That's actually called the substitution method because you're substituting in for y in both equations. But we're going to be talking about two ways of solving systems of equations today. One is elimination, the other is substitution. In my opinion, substitution is a little bit harder because you're probably less used to it. But that's okay because we're going to be learning all this stuff today. So with that...
I remember stuff now.
You remember it now?
Yes.
Well, good, because we're going to be doing it a lot. Okay, some examples. Graph both functions and then find the coordinate where they intersect. So before we even get into substitution and elimination method, all we're going to do is graph these two functions and see where they intersect. So first, y equals 2x. I'm hoping you remember this. It's just got a slope of 2 and a y-intercept at 0. So slope equals 2, y-intercept is 0. So that means we're going to start in the middle and go up 2 each time. And if you go the other way, we're going down 2 each time. And then if I were to draw a line connecting all these points, there's my first function. And then my other function, y equals x minus 2, I'll draw that in a different color. First, it has a y-intercept at negative 2. So y-intercept at negative 2. And the slope, hopefully remember, the slope is 1 because there's an invisible 1 in front of that x. So the slope is 1, so I've got these points all along here. And when I connect the dots, it's going to look like this. And then we see that intersection point right there. And we say the coordinate point for that is negative 2 in the x. And in the y, it's 1, 2, 3, 4 down. So there's my intersection point. So in other words, x equals negative 2 and y equals negative 4. X equals negative 2, y equals negative 4. That's how you solve these if I don't have, well, substitution or elimination method. If I can graph them, pretty easy. Now, why don't you try number 2 on your own? I'll give you about a minute for that. If you're watching the video, just pause it and go ahead. Okay, so time's up. Let's go ahead and see how we solve this. So first, the first function has a slope of negative 1/2 and a y-intercept at 3. So in other words, I start at positive 3, and then it's got a slope of negative 1/2, which means down 1 to the right 2. Down 1 to the right 2, down 1 to the right 2. And then, of course, up 1, left 2, up 1, left 2 for the other way. So I've got this line right here for the first one. And then for the second one, it's 4x minus 2. I just remembered when I did this example, it's not a whole number. So I apologize if that caused any confusion. But it doesn't matter. It doesn't have to be a whole number. It doesn't have to be on the grid. Basically, with the slope of 4 and starting at negative 2, you get there. And then up 4 over 1 there. Up 1, 2, 3, 4 over 1 there. And then down 4, 1, 2, 3, 4 over 1 there. And yeah, this is not going to be a whole number. As a matter of fact, if I had to guess, this point right here, and this is an approximation, but I would assume that point is about maybe 1.1 in the x, and then the y looks to me to be about, I don't know, 2.5. We'll say 2.5, but anything in between 2 and 3 is good. So in other words, the solution would be x equals 1.1 and y equals about 2.5. And that's fine. The good news is for the rest of the exam.
That messed me up.
Yep, I figured that would cause confusion. But anyways, basically, none of the answers for the rest of today will be decimals, so don't worry about that. It's possible to have decimals, of course it is, but I didn't want to be that mean, especially for a summer course, so I made it easier for the rest of it. Now let's talk about how you'd solve it if I didn't have a graph. In other words, we got the substitution method first, then we'll talk about the elimination method. So we already know how to find the intersection point using the graph. I'm not even going to explain that anymore. But now, I just want to say that we can solve it using substitution. We actually did this earlier today. Basically, the red line has an equation of x plus 2 because the slope is 1 and the y-intercept is 2. And if you don't believe me, look for it for yourself. And then the blue line, it looks like the y-intercept is 1, 2, 3, 4, 5, 6. And then the slope to me looks to be about negative 3. So negative 3x minus 6. And now if you want to use a substitution method, and this is an oversimplified version of this, but one thing you can do is just set the functions equal to each other. Keep in mind, this only works if the functions are written in y equals mx plus b. If they are not written in y equals mx plus b, this method won't work exactly. But I can set the functions equal to each other. So in other words, x plus 2 equals negative 3x minus 6. And now we just solve for x using algebra. So for instance, add 3x to both sides. We have 4x plus 2 equals negative 6. And then minus 2 from both sides. Looks like 4x equals negative 8. Therefore, x equals negative 2. That's my x solution. And of course, if I want to find my y, now all I need to do is plug in negative 2 in for x. So y equals negative 2 plus 2. I chose the top equation, x plus 2. Although technically you can also choose the bottom equation. It doesn't matter. You'll get the same answer. And I get y equals 0. So x equals negative 2, y equals 0. And if I look at the graph, it looks like that's exactly where the intersection point is, negative 2, 0. So it looks like I did it right. Any questions on that one? Yes.
So, my math teacher last year, she said that she said two things. One, whenever you have a negative, negative 3x, and the positive 1x, is it a thing where you always have to add where you so you can't bring the 1 over, you have to bring the negative 3 over because it's negative or a positive number?
No, I see what you're asking. Is that the end of your question?
Yes.
Okay. So it's actually not true that you have to do it that way, although it's certainly easier. Let me show you why.
Okay.
Because another thing I could do is subtract x from both sides, and you could then add 6 to both sides, and you'll get 8 equals negative 4x. And of course, you divide by negative 4, you'll get the same answer. But, I mean, when I was in algebra, I liked keeping the x positive as much as possible. Yeah. So that's what I would do.
Okay.
Okay. Now for the rest of the problems today, they're going to be harder substitution problems. And honestly, at least when I'm explaining this to my SAT kids, normally they have a lot of trouble understanding this substitution method. So we're going to see how well you understand it today. And if it's confusing at all, well, just rewatch the video because we're doing 8 examples or something like that today. So in this one, you cannot set the functions equal to each other. Or at least this left one, you cannot. The reason why is because they're both not in the form x equals, right? So then here's what I want you to do. One thing you can do, yes, you can subtract 4y from both sides, and then you can set them equal to each other. But I don't want to do it that way because it's not always easy to do it that way. For instance, this right one, this one's much harder to solve for y than the left one. So for that reason, I just want to show you what you're supposed to do. And what are you supposed to do? You're supposed to replace these x's right here with y plus 6. Let me explain that again. There is an x here, and we just said x equals y plus 6. So I want you to write where the x is, I want you to write y plus 6 right there. So in other words, it's y plus 6 plus 4y equals 1. In other words, I substituted x for y plus 6. And I can do that because it says x equals right there. That's the substitution method. And then I can combine like terms. So y plus 4y is 5y plus 6 equals 1. And then I would just subtract 6 from both sides. Looks like 5y equals negative 1. And I get y, oh, whoops, I meant negative 5. Sorry. And then you divide by 5 and y equals negative 1. And then if you want to find x, all you got to do is x equals negative 1 plus 6 because I plugged into the top function. It's definitely easier. And I'll get x equals positive 5. So the solution is 5 comma negative 1. Any questions there? Okay, good. And then now for the other one, we have x minus 2y equals negative 2 and y equals 3x minus 4. Since this is in the form y equals, I'm going to do the opposite this time. I'm going to replace this y with that y right there. Or in other words, 3x minus 4 with that y right there. So in other words, this one's much more complicated. It's x minus 2 parentheses 3x minus 4 equals negative 2. Notice the only difference between the first equation and this one is I replaced my y with 3x minus 4 because that's how you do substitution method. And now if we want to keep going, we've got to distribute that negative 2 to both terms. So it's going to be x minus 6x plus 8 because of the double negative equals negative 2. And so x minus 6x, that's negative 5x, plus 8 equals negative 2. Subtract 8 from both sides. Negative 5x equals negative 10. Divide both sides by negative 5. X equals positive 2. So there's my x value, x equals 2. And then again, if I want to find my y value, I can choose either the top one or the bottom one. I think the bottom one's going to be easier this time. It just looks easier to me. So y equals 3 times x, which is 2, minus 4. 3 times 2 is 6, so 6 minus 4 looks like y equals 2 as well. And there's the solution. Any questions? Okay. So then, next example. We have x equals y minus 1 and 3y minus x equals 11. Again, I'm going to do it a little faster now because I'm assuming it makes sense. But x equals y minus 1, I'm going to be plugging that right there in for x. It's going to be 3y minus parentheses y minus 1, the quantity, equals 11. Next, I distribute the negative sign to both terms. So 3y minus y plus 1 equals 11. And now I can combine like terms, so that's 3y minus y is 2y. And then I can subtract 1 from both sides as well, and I get 2y equals 10. So divide both sides by 2, it looks like we get y equals 5. And then for x, well, x equals y minus 1, so 5 minus 1 looks like x equals 4, and we're done. Any questions on that one? Okay then. How about you try number 2 on your own? And then pause the video. Oh, go ahead. Yep.
So like whenever you have like the y minus 1 in parentheses, like why do you say quantity?
I say quantity because when I'm reading this, let's just say I didn't say the word quantity. I would say 3y minus y minus 1. Okay. If I were to say it like that, it would be kind of incorrect because I would be saying this, 3y minus y minus 1. And the quantity implies the parentheses.
Because whenever I, like, oh, okay, I just saw the negative. Okay.
You're good?
Because I was just going to say, like, whenever, like, I'm doing it and it's not, like, if there's no timesing anything, like, I won't put, like, parentheses.
Right. That's right. In other words, if this was 3y plus y minus 1, exactly, you wouldn't need parentheses. It wouldn't matter.
Okay.
Okay, now for number 2, why don't you go ahead and try it on your own? And then I want you, for those watching the recording, pause the video, don't start number 3 until we go over number 2. And go ahead. And time's up. Even if you didn't finish, that's okay.
I just finished.
Excellent. So now, here, first thing I'm going to do is I'm going to plug in y for the y right there. I'm going to get 3x plus 2 times the quantity, x minus 4, equals 7. And then it's going to be 3x plus 2x minus 8 equals 7 after I distribute the 2. Now I combine like terms, so 5x, and then add 8 to both sides. I'll get 5x equals 15. Looks like x equals 3. And then if I want to find y just equals x minus 4, so 3 minus 4. Looks like y equals negative 1. There's my solution, x equals 3, y equals negative 1. And now again, go ahead and do number 3 on your own. I'll give you another minute for that. Number 4 I will be doing, so don't do number 4 on your own. Oh.
I'm trying to get 4y by itself, right?
I should probably explain.
I know how to do it. I'm just like...
No, you want to... The easiest thing to do is... No, the easiest thing to do is to get x by itself.
Okay. So
and you just do that by dividing by 2. Basically, the goal is you want it to get in the form x equals something, right? So if you want it to be x equals something, then I would divide everything by 2, and you'd get x equals 2y minus 4. And now you can plug that x in right there.
Oh, got it. Okay.
So, for this one, I already explained the first step where you divide both sides by 2. And then, now if you plug that in for x, it's going to be 2y minus 4 minus 3y equals negative 8. And now we've got the what we're used to seeing. So 2y minus 3y, that's negative 1y. I'll just write negative y. And then I add 4 to both sides. Negative y equals negative 8 plus 4 is still negative 4. Looks like y is going to equal positive 4. And again, if I want to solve for x, well, I can either do 2x equals 4y minus 8. I can also just use this equation, x equals 2y minus 4. So in other words, x equals 2 times 4 minus 4. That's perfectly fine. And then x equals 8 minus 4. Looks like x equals positive 4 as well. I'll admit that one was harder. And so basically, if you use elimination method and it's not perfectly set up, like for instance, this one was not perfectly set up, I had to divide both sides by 2, well then you have to solve for x or you have to solve for y. And that's okay because it's not that bad. But any questions on that one?
I kind of get it.
Well then we're gonna have more practice with number 4, so don't worry. Number 4 I'm gonna be leading because it's harder than you think. Basically, for this one, I have to choose to either solve for x or for y in either the top or the bottom. I think we're the closest, right now, we're very close to solving for y in the top equation. All we got to do is divide everything by negative 3. So divide by negative 3, divide by negative 3, divide by negative 3. I will get y equals negative 2x plus 4. Does everyone see that? Okay. So then now that I've got y, I can plug in negative 2x plus 4 into that y right there in the other equation. So it's going to be 4 times the quantity, negative 2x plus 4, plus 8x equals 16. And now it's going to be distributing the 4. It's going to be negative 8x plus 16 plus 8x equals 16. And this one's weird because the negative 8x and the plus 8x cancel, and so I just get 16 equals 16. This is a very weird answer, isn't it? As a matter of fact, the answer, it's one of two things. It's either no solution or it's infinitely many solutions. And since 16 does equal 16, the correct answer is infinitely many solutions. Infinitely many solutions. And that's perfectly okay. Now, I just mentioned a second ago it's either infinitely many solutions or no solution. How did I know it was infinitely many? Well, it's because 16 equals 16. In other words, if I got another result, like let's say 16 equals 8, and I know that's not true, then the answer is no solution. So this doesn't happen very often, but when it does, the reason why it happened is because all the x's and all the y's canceled out, and you're just left with 2 numbers on either side. Any questions on that one? Okay then. Next we're going to be talking about the elimination method. But before I explain the elimination method, I just want to show you when it's easier to use each method. So this method on the right, where it's already solved for x, and it's very easy to see that you're going to plug in y minus 1 right there, this is easier to use substitution. This is when I want you to use substitution. If you look at the right equation, this would take forever to solve for x or y. And even more importantly, the equation is lined up perfectly to add the functions together. Whenever you add the functions together, it's easier to use elimination. Go ahead.
I realized something.
Yes.
I think the reason why I was getting confused with substitution was because I kept thinking that the lining up thing was supposed to be for substitution and it's supposed to be for elimination.
Got it.
Yeah.
And so we're going to be doing elimination then for the rest of today. And so let's get started with this first example right here. So as you can see, these equations are lined up. In other words, the x is lined up with the x, the y is lined up with the y. But the problem is if I were to add these up right now, and don't write this down, just watch, I would get 3x minus 3y equals negative 6. In other words, I added everything together. This is not good because I still have 2 variables. I want one of my variables to cancel out or eliminate, which is why they call this the elimination method. So how do I do that? The answer is I got to multiply the entire top equation by negative 2. Why negative 2? You'll see why in 1 second. But when I multiply the entire top equation by negative 2, I get negative 2x minus 4y equals negative 20. And now if I line it up again with the bottom equation, I can see that when I add them up, the x is canceled. And that's why I wanted to do negative 2, because I knew that would make it cancel. By the way, I like to add the equations together. Some people like to subtract the equations. I'm going to be doing adding the equations together today, each time, which means one of your x's needs to be positive, one needs to be negative in order for them to cancel. So in other words, we get 0 minus 9y equals negative 36. Divide both sides by negative 9. You're going to get y equals positive 4. And then if you want to solve for x, we got to plug it into one of our equations. I'll choose x plus 2y equals 10. So then x plus 2 times 4 equals 10. X plus 8 equals 10. Subtract 8 from both sides, x equals 2. And there's our solution. Any questions on that one? Okay then. For the rest of today, we're going to be doing solve using elimination method. So for number 1, we have our choice. We can either cancel out the x's or cancel out the y's. Both, you can do both. Let me explain. If you want to cancel out the x's, for instance, you would multiply the bottom equation by 3, because that'll get it to cancel out. And if you want to get rid of the y's, you'd multiply either the top or the bottom by negative 1, and that'll cancel out the y's. So I'm going to ask the audience, what would you like to do? Cancel out the x's or cancel out the y's?
Cancel
Go ahead.
Cancel out the x.
Okay, then that means we're multiplying the bottom one by 3. And so that's going to look like negative 3x minus 12y equals 3 times 14, that's 42. So negative 42. And then I just write the other one. It doesn't matter if I write it above or below. It's going to be the same thing. And when I add these together, the x's cancel. I'm going to get negative 16y equals negative 42. And this can't be right, because this is not at all the answer I got. I must have made a mistake. Hold on.
Don't you have to subtract like negative 42?
Oh my god. Yeah, I didn't subtract the 10. Terrible. Yeah, that's why. Yeah, negative 42 plus 10 is negative 32. This makes sense. Y equals positive 2 when you divide by negative 16. And now if I want to solve for the x, I can plug it into either the top or the bottom. I'll choose the top this time. 3x minus 4y, and y is 2, equals 10. So then 3x minus 8 equals 10. Add 8 to both sides. 3x equals 18. And then divide by 3. X equals 6. And there's our solution. Any questions on that one? Okay, next. Number 2. X plus 3y equals 9. And negative 4x plus 7y equals 40. Again, I get to choose if I want to do x or y. I think if you choose y, I think that's silly. I think this is way too hard to choose y. Because x is simple. You just multiply x, the top equation, by not negative 4, positive 4, because the bottom one's already negative. So in other words, it's going to be 4x plus 12y equals 36. And then the bottom one, just rewrite it, negative 4x plus 7y equals 40. And then just add these two together. So for instance, 12 plus 7 is 19y equals, it's going to be 76. And if you divide both sides by 19, and I know that's hard, but if you have a calculator, you'll get an answer of 4. So y is 4. And then again, if I want to solve for x, then all I'm going to do is say x plus 3y, and y is 4, equals 9. 3 times 4 is 12, so x plus 12 equals 9. Subtract 12 from both sides, x equals negative 3. And there's our answer. Any questions on that one? So then now, number 3. I want you to do number 3 on your own. And if you're watching the recording, you can pause the video. Okay, I'm going to say time's up. If you haven't finished, that's okay. So basically, for this one, you can choose to either solve for the x or the y. I think solving for x is a little bit easier, although the y isn't too bad. So I multiply the top one by negative 3, because that's going to cancel out the x. I'll get negative 6x minus 36y equals 0 times anything is still 0. And then on the bottom, it's 6x minus y equals negative 37. So it looks like the x's cancel, and I get negative 37y equals negative 37. And then I just divide both sides by negative 37. So y equals positive 1. And now if I want to solve for x, then I just plug into one of the equations. Let's do the top one. So it's going to be 2x plus 12y, and y is 1, equals 0. 2x plus 12 equals 0. And now I got to solve for x, which means subtracting 12 from both sides. So 2x equals negative 12. Divide both sides by 2. X equals negative 6. Any questions on that one?
No, but I did the other equation because that one was easier.
And did you get the same answer?
Yes.
Perfect. So there you go.
So it doesn't matter like what equation I use, right?
Nope, because you should get the same answer.
Okay.
And now for the next one I'm going to do. And the reason I'm going to do it is because no matter which equation you choose, no matter which variable you choose, it's not going to work. And the reason why is because you got to change both the top and the bottom. Let me show you. I'm going to solve for the x's. I'm going to try and cancel out the x's. If I multiply the top equation by 3 and the bottom equation by negative 2, that's going to get me to cancel it out. Just watch. Multiplying the top one by 3, I get 6x minus 33y equals negative 16 times 3, that's negative 48. And then the bottom equation, it's going to be negative 6x, double negative, negative 4, negative 2, will make plus 8y equals negative 2. And now I'm going to add these two equations together. But as you can see, the x's will now cancel, and that only happened because I changed both equations. And sometimes you have to do that. So the x's cancel. Negative 33 plus 8 is negative 25y equals negative 50. And then I just divide both sides by negative 25. So y is going to equal positive 2. And then if I want to solve for x, it's going to be 3x minus 4 times 2 equals 1. I chose the bottom equation, but remember I can choose the top as well if I wanted to. And so that's 3x minus 8 equals 1. Add 8 to both sides. 3x equals 9. X equals 3. And there's our solution. Any questions on that one? Okay, so then the last problem we'll ever see together, number 5, and then it's the end of the summer course. Well, of course you have to do the homework, but go ahead, try solving it on your own using that strategy. If you want my advice, try and cancel out the y, and go ahead. Then now is the time to unpause your videos, and let's see if we can get the answer. So as I suggested, I'm going to solve for y. If I multiply the top one by 3 and the bottom one by 4, it should work. So for the top equation, I get 15x minus 12y equals 9. And for the bottom equation, it's negative 28x plus 12y equals 4. I add these two equations together. For the x's, I get negative 13x, the y's canceled, and 9 plus 4 is 13. So it looks like x is just negative 1. And then if I want the y's, well then I can choose the top or the bottom. I'll choose the top. 5x, so 5 times negative 1, minus 4y equals positive 3. Negative 5 equals negative 4y, I can't say it right. Negative 5 minus 4y equals 3. There we go. Add 5 to both sides. Negative 4y equals 8. And then just divide both sides by negative 4. Y equals negative 2. And there we go. And before we wrap up, I guess first of all, any questions? Okay, great. And before we wrap up today, I just want to remind you, why did I do these free summer courses in the first place? What did I say at the beginning of week 1? I did it because I want to become the greatest tutor of all time. And so even though I spent 8 hours a week, probably over that, because the lessons, it takes me time to prepare them, takes me time to even create the lessons and the homework and everything like that. Takes me, a few, like 15 minutes to send out the emails each week for all 6 classes that I'm doing this summer. And again, all of it's for free. And it's not to make you feel guilty. Although if it did, then I apologize. But the reason why is because if I want to become the greatest tutor of all time, then what do I have to do? It means that I have to provide more value for you than I'm asking in return. And so that's why when I very first started Dan the Tutor back in summer of 2020, in the middle of the pandemic at the start, basically what I had to do was no one knew who Dan the Tutor was. None of the schools would get back to me. No teachers would get back to me. So I literally had to tutor for free. I would find parents on Facebook and I would offer to tutor their kids for free. And I spent the first 3 months of Dan the Tutor tutoring for not even a single penny. And it wasn't until the fall, the beginning of the fall, that finally I got my first paying customer. And then that first year, I ended up having 30 paying customers between the fall and the spring semesters for a lot of college students. So let me be the first to tell you that if you want to succeed in life, it's going to take a lot of work, especially if you're starting from zero. Now, the good news for you is you don't have to make your own company. That's not what I'm saying. But what I am saying is the only reason I'm able to do what I do, and I think you've been able to tell by now, I love what I do a lot more than most people love their jobs. And so if you can find something, whatever you do in life, that you love to do, that you would do it for fun anyway, and it brings joy and value to other people, then you're going to live a very fulfilling life. And so that's my advice to you, that whatever you do for 40 hours a week, or in my case, 50 to 60 hours a week, then I hope it's something that brings you joy and really feels like you're accomplishing a goal. So with that message, I leave you. Have a great rest of your summer and a great school year.